All right, so for another application where we're given formulas, this one's a little tougher because what we're being asked to find, so algebra concepts determines that their revenue and cost functions to produce the gaming hit Algebra blasters, which I know you guys all bought, can be modeled with the following functions. So R of X is this quadratic right here, and that's your revenue, and your cost function is 3x plus 7.5, which is a line. X is the number of the games that we produced in hundreds, and R of X is the revenue, and C of X is the cost in dollars and thousands, all right, producing these games. So the first thing we need to do is remember that what profit represents, right, profit equals the revenue that I have coming in minus the cost, right? Revenue is how much comes into my company, cost is how much goes out. So if I subtract the two, I end up with how much profit that I made. So based off of what I have here, my revenue function would be 110x minus 2x squared, and then we're going to subtract the 30x plus 75, right? And so if we finish this off, let me call this P of x, right? We're going to distribute that minus sign. So we're going to have a negative 2x squared. This is going to be a 30x and a minus 75. 110x minus 30x would be a positive 80x and then minus 75. So there's basically our profit function, all right? And so we just did part A, all right? So P of x, let me rewrite it real clearly here, right, is negative 2x squared plus 80x minus 75. Just check my math real quick. All right, yeah, 11, okay? So what numbers of games produce a maximum? What is the amount of the maximum profit? Well, we are expecting a maximum here, right, because we are quadratic and our lead coefficient is -2. So if we were to graph this, I would have a parabola opening downwards. So to answer A and B, I'm back to finding the vertex again. So the number of games produced, that's X. So this would be the H amount that we're looking for. And the amount of the maximum profit, right, that would basically be the K value that we have in dollars. All right, so we basically have to find the vertex. Again, the problem just above, I use the modify completing the square process. To save myself a time and heartache, I'm just going to go ahead and use our vertex formula. So we know that H is negative B over 2A. So plugging in things, I got negative 80 divided by 2 times -2. So this is basically negative 80 divided by -4. A negative divided by a negative is a positive. 80 divided by 4 goes in 20. All right, now we have to be careful here because it's not just 20, right? Because X was the number of games produced in hundreds. So in actuality, right, the number of games produced, right, would be 20 and then add a couple more zeros. So there's actually 2,000 games that were made to maximize my profit. All righty, to find K, K is basically my profit evaluated at the H value that I got. So we're looking at P of 20. So we got -2 times 20 squared plus 80 times 20, and then minus 75. So this will be -2, 20 squared is 400. 8 times 2 is 16, and we have a couple of zeros, and then minus 75. This is -800 plus 1600 minus 75. So adding my negatives up together, we essentially have 1600 minus 875. So doing a little bit of math here, we're going to borrow. We get 5, we get 2. Borrow again, right? We get 7. So it looks like we have 725. However, right, since the R and the C were in thousands of dollars, that means my profit is also going to be measured in thousands of dollars. So we have 7025, and then we tack on 3 zeros to represent thousands. All right, so there is basically Another application where in this case, we're maximizing profit. We're given my revenue function and my cost function. We build my profit function, realize that it's a quadratic with a negative lead coefficient. So to find the maximum profit, we basically look for the vertex. Using the vertex formula, we find what we have. And then again, be careful with the language in the problem, right? 20 and 725 are technically the right answers, but when we go to the units described, right, the games were measured in hundreds, or excuse me, in hundreds. So this would be 20 times 100. And the dollars were measured in thousands. So basically 725 times 1,000, which gave us our two answers. All right, so there are some examples of where we're maximizing or minimizing or doing an optimization problem where we are given formulas to use and to build our functions. All right, much more tougher problems coming soon, but I'm going to do that in some videos. See you guys.